Khurram, welcome to Telesemana. Tell us what Powerwave is presenting here at FutureCom. What are you trying to communicate, I guess, the operators or future partners?
Well, we're very excited to be here at FutureCom. We've got a very exciting booth where we've got a lot of new products we're showing on the existing product portfolio of antennas, amplifiers, radio heads, advanced communications equipment for 3G and 4G technologies. At the same time, I'm speaking today on a topic called Inside Out, which we think is a disruptive technology strategy for an operator to deploy a 4G wireless broadband network. And basically the idea is that the existing networks were designed with the macro cells to cover the highways and freeways, more like a car phone. But wireless is going everywhere, wireless is ubiquitous, and to really make wireless broadband real for the end consumer, you need to really be directed towards the inside of the buildings, inside of the homes, and drive the architecture to be inside out. So really the opposite of today, it's outside in. And that means, looking at more advanced technologies like picocells and femtocells, and also looking at more distributed radio architectures to provide the ubiquitous, seamless experience. The idea is that wireless broadband is just like your broadband at home, but with a mobile connection. And today's networks don't do that. And coming into Sao Paulo this morning, I felt the same experience. I was in the taxi and my phone was working. I get into the hotel, it doesn't work. I try to get on a Wi-Fi connection. It's very slow. Everybody's using it. It's unlicensed. So I think the user experience is a critical piece there. So all the products that Powerwave is showcasing for 4G are allowing you to get that high-speed broadband wireless experience.
Okay, tell me how the architecture would work, because obviously to do that out, in out, you need to have obviously fixed broadband somewhere in the building.
Right. Yes and no. Yes and no.
Okay, so tell me what would be the architecture where no, since in Latin America probably what we need is an in-out strategy.
That's a great idea. Well, one of the things I remember when I started working wireless broadband a decade ago, Latin America was one of the first to adopt WiMAX. And WiMAX was fixed wireless replacement. And you can think about that the end last 100 feet or 200 feet could be Wi-Fi, could be 3G, could be any of those technologies, but the mile going back to the tower could be the WiMAX connection, a fixed broadband modem that has WiMAX coming in and Wi-Fi or 3G or LTE coming out. So that's an option for those countries.
Or microwave technologies?
No, microwave micro or WiMAX technologies. At the same time, I think that you also can think about more distributed cells, not having these big towers, but low power cells in neighborhoods. I mean, as I was driving into Sao Paulo, I see a lot of buildings. You can have at the side of every building a small pico cell that's distributed radio. Now, you're right, you need fiber connectivity or some connectivity. You can do point-to-point microwave, you can do point-to-multipoint microwave, lots of different ways to do it. The idea is that, you really want the user experience to be higher speed. And the other factor I didn't mention earlier was the battery life. I mean, a lot of us like to watch a movie, like to watch video and audio, and once you do it for a couple of hours, if you're screaming at the base station, you're going to be drained battery pretty quickly. So I think with Inside Out, you'll have a much better user experience in terms of battery life, throughput, and the fact that you get coverage everywhere, instead of having some places you have coverage and not.
Now that I have somebody here that knows about antennas, let me ask you this question. What's up with MIMO? Because, we hear MIMO here, MIMO there, but...
Well, the interesting piece, this is the other piece with Inside Out, is if you recall, MIMO the first MIMO implementations have been in Wi-Fi. And Wi-Fi is mostly indoors. So again, with Inside Out, you can really take the advantage of the MIMO, because MIMO really requires a scattered channel. And if you have low base station antennas and low height equipment, you get better channel conditions for that. Unfortunately, in an outdoor environment, you get a lot of line of sight. And MIMO, you don't get the benefit of a line of sight. Now, all our antennas are MIMO ready. So, you'll look at our antennas are 2x2 MIMO, 4x4 MIMO. It requires not only on the base station side, but also on the device side. Both have to work. And if you have a line of sight channel, it really doesn't help you. So I think that as you look at more distributed architectures and indoor applications, you're going to see MIMO be more prevalent. Yep.
So MIMO deployment is not correlated with LTE deployments, actually?
Well, yes, it is, because I think one of the things that we did with the LTE standard and with WiMAX is we put the hooks built in, so you have MIMO integrated with the baseband modem, so really have the full functionality. In 2G and 3G, MIMO was an afterthought. Like, okay, we built the system now, maybe put two antennas and see how it works. It has to work all the way with the signal processing with the baseband. So I think with 4G, you have the capability to do a lot with MIMO, and that's the advantage.
At some point in the past, when I attended CTIA and Mobile World Congress, there was a lot of discussion of antennas that moved and changed their position and so on. How has that progressed in emerging markets like Latin America, the implementation of these type of systems that supposedly make the network much more efficient?
Well, I think the first thing of antennas is remote electrical tilt. And remote electrical tilt is available in all the antennas now we have. So from an iPad, iPhone, you can change the antenna tilt. That will give you better coverage. I think that's standard in all our antennas. As you go to more advanced features like beam forming and beam shaping, I think that's also what I call it in the area of spatial processing. So they're all part of the MIMO family of applications. And the challenge has always been, how do you put multiple antennas at a cell site, at a big tower? You need a lot more spacing, you need more cables and weight and all this stuff. I think as we look forward with more integrated RF, integrated electronics, you're going to see what we call active arrays, which are more advanced radio and antenna integrated. That gives you better performance, better capability. The traditional systems are not as capable because it's more antennas and radios are separated, and that doesn't give you the full performance. So yeah, you're right, those technologies haven't come to bear right now.
And finally, we're hearing operators complaining that their data networks are being squeezed by the users using their data traffic.
Right.
How can antennas, because obviously they say because our spectrum resource is scarce, how can antennas help in increase the capacity instead of just adding new technologies all the time?
Well, I just mentioned active arrays are a very good way of increasing capacity, because the capacity is really uplink capacity, and what the active arrays do is they integrate the antenna and radio, so your link budget is increased up to 3 dB. So now you don't have those losses that are happening between the antenna and the radio and the cable losses. So you can get 3 to 4 dB advantage, which can significantly improve your uplink capacity, number one. The second thing with the antennas, as you know, is with much more advanced antenna technique, we can pinpoint the user to the various locations, so you can get the highest data rate possible. And data rate is a function of carrier interference. So antennas, the beauty of antennas is they give you signal power, but they can also be mitigating interference. And most of these 4G systems are interference limited. So I think antennas will play a big role. I think you're already seeing that spectrum is scarce, so if you have to have more reuse to get better reuse, you need to make sure your antennas are rejecting the interferers. So there's a lot of opportunities for that, and a lot of our antennas are being deployed in 4G systems today, in Clearwire in the United States, in Asia Pac region, and moving forward with the rollout of 4G in the United States, there's a big emphasis on antenna design to make sure we mitigate interference for those.